Boyle's law. This law explains the relationship between the volume and the pressure at constant temperature of a fixed mass of gases. So here we are only discussing about the volume and the pressure, which are varied. But the temperature is held constant. Means that we don't care about the temperature because it is held constant. No variation of the temperature. And that is why Boyle's law states that the volume of a fixed mass of a gas is inversely proportional to its pressure at constant temperature. Mathematically, pressure is inversely proportional to volume. Therefore, this proportionality constant is removed. And this relationship is that once the volume is increased, there is a decrease in pressure. But once a volume is decreased, there is an increase in pressure. That is the meaning of this definition. Once you are increasing the volume, you are reducing the pressure. Once you are decreasing the volume, you are increasing the pressure. That is what now we can discuss. Therefore, mathematically, we learned about variation in mathematics. Pressure is equal now to K over V. Means removing the proportionality constant, which is the K. And this constant is what we call it temperature. And therefore, this is what we would have written. Therefore, at different conditions, for the first condition, we have P1 is equal now to K over V1. This is the first condition. And this gives the first thing. Therefore, once you look for this one, making the subject, now K is equal now to P1 V1. This is what we call it the first equation. And then once the pressure is changing, we wish also the volume will be changing. What if now the pressure is changed to P2? It will be equal now to K over V2. Now the volume also will be changed. But the temperature will remain constant. From then there, we'll be having K is equal now to P2 V2. Now this gives the second equation. Now at the first condition, this is the second condition. That means pressure was changed and then also volume was changed. As I've said here, once you are increasing the volume, you are reducing the pressure. Once you are reducing the volume, you are increasing the pressure. Simply because they are inversely proportional to each other. And therefore, looking at this equation and this one, you find K is constant to every equation. Means this equation will be equated. Therefore, P1 V1 must be equal now to P2 V2. This is what we got. Now this equation can definitely be used to determine what is missing. If now you find there is a variation of pressure and volume, that is Boyle's law. So you must apply the Boyle's law. Now, when you can represent this law graphically, you can represent this law. You plot, let's plot it there. Here we have pressure. We have pressure here. And then here we have volume. The graph will be seen to be like this one. Means when you start checking at this point, you will find this is temperature. This is pressure. Let's say this is pressure. Pressure 1. Then once you look, you check out. Now the volume is at this one. This is V1. Once you look at another point here, you find the pressure is reduced while the volume is increased. Once you take the other point right here, you will find pressure also is reduced, while the volume is increased. So this describes the law. But if now you want to find data, you want to draw the graph with a straight line. It is all about it. The other one is here. Here it is 1 over volume, and here it is pressure. So the graph of 1 over volume with pressure is the straight line, the straight one. Means when pressure is at this one, also 1 over volume is at this one. When the pressure is at this one, then 1 over volume also is at this one. So this is the 1 over volume against the pressure. And this is the volume against pressure. So this is the direct proportion. That is what we are saying. Pressure is that proportion to 1 over V. Direct proportion to 1 over V. So when you are increasing 1 over V, also you are increasing pressure. So this gives this graph. But pressure is inversely proportional to 1, inversely proportional to volume. Inversely proportional means when you are increasing the volume, you are reducing the pressure. When you are reducing the volume, you are increasing the temperature. So graphically can be represented this one. This is how now we can represent what we can call it Boyle's law graphically. Example is a gas in a cylinder occupies a volume of 465 milliliters. Now means the volume was equal now to 465 milliliters. This was recorded when the pressure was equal now to 725 millimeter of mercury. So when the volume was at this one, 465, the pressure was recorded 725. As you can see, this is according to the principle. The volume was recorded smaller than the pressure. Why is it so? Because once volume is reduced, pressure is increased. Then the question is, what will be the volume of the gas? What will be the volume, the second volume, when the pressure was recorded as 825 millimeter of mercury? What will be its volume? Therefore, because now we're talking about pressure and volume, we just discussed about from Boyle's law. We say P1 V1 is equal to P2 V2. Then we have to substitute what we've been given. Pressure 1, we have 725 times volume 1, 465. Is equal now, second pressure, 825 times V2 is absent. Then we divide by 825. Therefore, mathematically, the second volume will be equal to 408.60. This is, volume was recorded as milliliter. That is the milliliter. Now this is the volume. As you can see, before the volume was recorded as 465 millimeter, and then milliliter. And then when you look at the volume, this volume was recorded when the pressure was this one. And then we have seen volume that was recorded 480 when the pressure was increased. You can see the pressure was increased to 825. Then the volume was reduced to 408.6. Before it was 465. Now it is 408. Simply because there is a greater pressure that's all recorded. As you conclude by saying, once you find the volume, pressure is inversely proportional to this one. When this one, pressure is increased, volume is the result of decreasing the volume. But the pressure is reduced is a result of increasing the volume. So you may see from the question, pressure here is greater than the volume. Then you keep on increasing the pressure, we expect the volume to be less than 465. And that is what is been verified here. So this is less than this one because the pressure was increased. So according to Boyle's law, once you are increasing the pressure, you are reducing the volume. Once you are reducing the volume, you are increasing the pressure. Now, means pressure is recorded much greater when the volume is reduced. So that's all about it. Boyle.